discriminant is. So the discriminant has to do with the quadratic formula, which I said again, you have to memorize. Hopefully it's not too bad. And the discriminant is a very particular part of the quadratic formula. It is what we called yesterday the radicand. Is that not true? Okay. It's what we called the radicand yesterday, which is the stuff under the radical. But for the quadratic formula, it gets a special name called the discriminant. It's b squared minus 40c. And the discriminant is going to tell us some nice things about our graph. And we're going to explore those 4 cases with the charts below. Alright, so for each one, we're going to calculate the discriminant, and then we'll come back and fill in the blank. So case 1 here, I have a quadratic x squared plus 3x minus 10. And the first thing I want to do is calculate the discriminant. Now it says here in your table, the discriminant is the b squared minus 40c. It's always that part under the radical. So let's calculate that number. So what's b in this problem? 3. So we have 3 squared minus 4. A is 1. C is negative 10. I want you to take your calculator for me. Tell me what is the value of that discriminant? 49. All right. Now, this is one particular case, but we're going to use this example to cover all numbers of this kind. And this number is a special kind of number. Can anyone think of what might go on this slide? A perfect square. So the first case we're going to look at is what happens if the discriminant, or the stuff under the radical in the quadratic formula, is a perfect square. So let's use the quadratic formula, let's put it back in our brain, and calculate what are the actual roots of this graph, because that's what I'm trying to find. When the number under the radical is a perfect square, what does that tell me about the x-intercepts? So let's use our formula, x equals. Who can tell me what I have to do first in the quadratic formula? X, negative b. So what's the opposite of b? Negative 3 plus or minus the square root of 49. Now, what normally goes under the square root? Can you tell me? B squared minus 40. See, we already found that number. All over 2 times a. So yesterday, what did we do with that square root of 49? We simplified it. And what does that simplify to be? 7. So I have negative 3 plus or minus 7 over 2. And we know we're going to get rational roots because I have no square root, no I. But I said you can't leave your answers like that. You have to tell me what are the actual numbers. So you have to calculate negative 3 plus 7 over 2 and negative 3 minus 7 over 2. So what's the one on the left here? Negative 3 plus 7 over 2. It's 2. Okay, and negative 3 minus 7 over 2? Negative 5. All right. So, how many answers does this have? 2. And what kind of numbers are they? Irrational. So that actually, can I move the screen up? Fills in the top right box up there. The number of roots is 2. The nature of them is that they are rational. And that's what the rule we need to memorize today. Okay, we need to know that when I have a discriminant that is a perfect square, I get 2 rational roots. That's what we're learning here. Okay, so if I have 2 rational roots, can I factor that quadratic? Yes. Okay, and let's sketch a graph of the quadratic. So pull out your calculator, and let's type x squared plus 3x minus 10 into your calculator. We're not going to make a formal graph, but we're at least going to see visually what does that look like. Okay, so that's your parabola. You can see that it crosses at negative 5 and 2, crosses the x-intercept, those are rational values. So we'll just make a nice little picture here, something like that, and you can label that one of those roots is at 2 and negative 5. That's all we have to do for our sketch. All right, so as we go on today, I'm going to keep coming back and making sure you still memorize that. So if you have a perfect square, how many roots do you get? And they are rational. All right, the next case number 2. Let's calculate our discriminant to see what kind of numbers we're working with here. B squared, so that's negative 6 in parentheses squared, minus 4. A is 1, C is 7. And go on and calculate that value for me. It's 8. Good, so D equals B. Now what do you think is going to fill in that blank? The discriminant is not a perfect square. So it's a positive number, 8, but 8 is not a perfect square. So what does that tell us about our roots this time? Well, let's figure out what the roots are with the quadratic formula. So if x equals, what do I write first? Positive 6 plus or minus the square root of 8 over 2. Alright, does my square root simplify this time? It does. So if you need to do the work off to the side, you can figure out what is the square root of 8. Anyone know? Shout it out. 2 radical 2. So 6 plus or minus 2 radical 2 over. Alright. Does this simplify anymore? Yes, what simplifies? Everything, yeah, except the radical. The radical 2 is going to stay the same. But what's 6 divided by 2? 3 plus or minus radical 2. I could put a 1 there if I wanted, or I can just write it as 3 plus or minus radical 2. But I'll put the 1 so you see that I divided. 2 divided by 2 is 1. Well, how many roots is that for my number in nature? It is technically 2. And if you forgot, remember it's 3 minus radical 2 and 3 plus radical 2. It's just written condensed. So that's 2 roots. What's their nature? Irrational. Alright, so if my discriminant is just a positive number that is not a perfect square, I get 2 irrational roots. Can I factor a quadratic with 2 irrational roots? No. Alright, let's sketch the graph for this one. So what is the quadratic? X squared minus 6x plus 7. So it kind of looks similar to the last graph. I saw the parabola. It still crosses the x-axis. It's just where these cross this time are irrational. So I still have x-intercepts. They're just not nice numbers. So when I label them, I'll just label one as 3 plus radical 2, and the other one is 3 minus radical 2. All right, flip your page when you're done writing. And let's review real quick. If you have, so do this without looking, if you have a discriminant that's a perfect square, what's the number in nature of roots? Irrational. What if it's not a perfect square? 2 irrational. All right. Next one. Let's find this discriminant. B equals. So I have the opposite of B. So positive, or no, I'm sorry. I'm doing the quadratic formula. I'm jumping ahead. We want to do the discriminant. B squared minus 4AC. 0. Yeah, 100 minus 100 is 0. So the discriminant, the top part, the case, is the discriminant is equal to 0. Well, let's see what that does, because that's a little bit different. Let's calculate our roots. So now we're going to use the quadratic formula. So there's the opposite of b, which is positive 10 plus or minus the square root of 0 over 2 times a. Well, what's the square root of 0? 0. So I have 10 plus or minus 0 over 2. And when I add or subtract 0, does that give me different numbers? No. So I really don't even need that part. I just have 10 over 2, which equals 5. Well, what do you think the number in nature is here? 1 rational. Now, I will tell you, technically speaking, there are 2 roots there. But we don't know about that yet. We're going to learn that later in the year. So for now, we'll say it's 1 rational, but it's actually called a double root. There's something called multiplicities of roots, which we'll do in the spring. But for now, we can say there's 1 rational root. If there's a rational root, can you factor the quadratic? Yep, even if there's just one of them. So let's look at the graph. What does this 1 root look like? X squared minus 10x plus 25. Oh, I did something wrong. What did I do wrong? Minus. Oh, that would do it. Okay. Nice. I give up. I'm retired. Okay, third time's the charm. There, that's what I wanted to happen. That graph. Okay, now the cool thing about this graph, how would you describe this to someone? What would you say happens at the x-axis? How is the parabola, is it like? It's not, is it crossing through the axis? Yeah, it's a minimum. I say it bounces. I like to say it comes down and bounces off the axis. So you can say it touches. But here when there's just one root, that's just the one time, the one place that the graph actually touches the axis. So your sketch here, that's just a drive. Alright, one more case. So before we move on, let's see what we know. So if I have a positive number that's not a perfect square as my discriminant, what's the number in nature? I went out of order this time. Not a perfect square. 2 irrational. What if I have 0? 1 rational. Okay, a positive perfect square. 2 rational. All right, last case. Let's calculate our discriminant. See, you already almost have them memorized, so it's not that bad. Discriminant here. Let's see. Negative 8 squared minus 4 times A times C. Find that discriminant for me. Negative 16. So what goes in the blank up here? The discriminant is less than or smaller. Yeah, either one. Less than 0. Alright, so I'm sure you can kind of get to this point what's going to happen now that you've seen the pattern. But let's still calculate the roots here. X equals opposite of B, so positive 8 plus or minus the square root of negative 16 over 2A. Okay, so when I simplify this, I get 8 plus or minus what? 4I over 2. Does that simplify? Yeah, how does it simplify? Divide both those by 2, yeah. So it'll be 4 plus or minus 2I. How many roots is that? 2 and half. What's their nature? Imaginary. Yeah, they're not irrational. They're imaginary. Not the best handwriting, but it's okay. Can you factor a quadratic and get imaginary roots? No. Alright, let's visualize what it means to have these imaginary roots. So last graph, x squared minus 8x plus 20. Now for this graph, this is the only one that doesn't cross the axis. Right? Because its roots are imaginary, they're not real. So if it has roots, I just can't point to where they are because I don't know because they're not real. They just don't touch the real axis. So it's just kind of floating in space. And I can't even label them because I don't know where those roots are. Alright. Feel like you understand how the discriminant works? And then we got a little more quadratic formula. A multiple choice, a quick question at the bottom when we're finished. Which of the following discriminants belongs to a parabola that has 2 rational x-intercepts? So what type of discriminant has 2 rational x-intercepts? Perfect square, so that would be C. That's easy. If you know the rule, that's a quick problem. If you don't know the rule, then you have to graph a bunch of different things and test it out. Given that a quadratic has a discriminant of 19, identify the following. Well, that's a positive number, but is it a perfect square? No, so what's the number in nature of roots for not a perfect square? 2 irrational. And could you factor a quadratic as exponent? No. Alright. That's it. That's what I have for you. I have some practice. And